Hi, welcome to Dinesh Tech Bytes. This is a new series called Fix My Kubernetes Cluster. Yeah, this is how the format of this series will look like. So we will create an issue, like we will create a brand new Kubernetes cluster, break the cluster, and create some pods or some resource to test the actual issue and fix the Kubernetes cluster. Create some pods or some resources to check if the actual fix is worked or not. Finally, some bytes like what are the concepts behind this fix? How did we found the problem? And finally, we can also see how did we initially break the cluster. Let me go to the terminal. I'm going to create a brand new Kubernetes cluster using kind. Kind will create Kubernetes cluster on top of Docker. So if you see, I don't have any Docker containers up and running. I'm going to run a script called create cluster with issue, which is going to use kind to create a single node Kubernetes cluster using Docker containers. In this Kubernetes cluster, we are going to have all the components up and running. Then we are going to deploy some pod and see what is the actual issue happening. Now, if you see, the Kubernetes cluster has been created and we are waiting for all the nodes to be ready. Once the node is ready, we will deploy the actual uh, pods which are going to run in this cluster. Then we will see, yeah, the pod is getting created and we will see what is the issue and how to fix it. Yeah, if you see out of two pods, one pod is running, another pod is in pending state. Can you help? Can we help in fixing the pending pod and make it running? So if you see, let's maybe do once again kubectl get pods. Yeah, one pod is pending. Then we can do kubectl describe that pod 2, which is in the pending state to see if there is any error that shows in the describe. We see no events, no error, nothing is there. So, but if we see the describe of the Nginx pod 1, it's been running successfully fine, everything is fine. Maybe let's see if we can delete the Nginx pod 1. It's deleted. Now let's do kubectl get pods. We have only one pending pod. Let's do kubectl apply -f pod 1, which will create the Nginx back. Now let's do kubectl get pods to see if the Nginx one which was running before is still running after we delete and recreate it. Kubectl, yeah, if you see it's still running, even though it created 12 seconds before, it's running, but still Nginx is not at all running. Let's see the difference between the pod 2.yaml, which is in the pending state, with the pod 1.yaml, which is going into running state even after recreating it. Yeah, if you see one difference, we are specifying the node name here in the pod 1, which go into the running state, but this is not having the node name. Okay, now which is the component which is responsible for assigning this node name? In the Kubernetes, we have multiple components. The one component which is responsible for doing that is scheduler. So let's go ahead and see if the scheduler is there or not. kubectl get pods -n kube system. Yeah, if you see, we have all those etcd API server control plane, but scheduler is missing. Because there is no scheduler, uh, nobody is there to assign a pod to the node. So scheduler is not running, so it's in pending state. Let's make sure we run the scheduler so that this pending pod, kubectl get pod, this pending pod will go into the running state. That is our assertion once the scheduler comes up. So this is a kind-based cluster. So let me SSH into it. So I will do docker exec -it 157, the ID of the container, and bash. Yes, I am into it. Now, if you see, this is a Kubedium based cluster. The kind internally use Kubedium. So Kubedium actually creates the cluster using static pods. So what is static pods? Now, pods, when it gets created, it will go to the API server. API server will store it in the etcd. Scheduler will pick it up. Scheduler will decide which node to go. Then it will assign it. Then the actual kubelet will take that pod and it will run it. But static pods are the special type of the pod in which the pods are directly managed by the kubelet. So which means kubelet will directly create the pods and directly watch it and make sure it is always running. It will never go to the API server and scheduler. So that is the reason by using the static pods, we are able to run the API server, etcd, everything in the single node cluster itself. Now, if you see, we are running, kubelet will be running by default as a service in the one node control plane. Yeah, if you see, the user bin kubelet is running with some configuration. While we see one configuration called, we have, this is the configuration for the kubelet. Let's print it and see that configuration. It's having a lot of configuration for the kubelet, but one thing that is interest to us is static pod path. Let's see what is there in this path. Yeah, if we see in this path, we have etcd, kube API server, kube controller manager. So whatever YAML, okay, let's see one YAML file also. Let's go inside this static path, and let's say we want to do cat etcd. So if you see, it's an pod.yaml which contains the image for the etcd. So if you put any YAML file which is of a pod type, the kubelet will watch this location and it will start running it. Because the scheduler is not there in this path, scheduler is not running. So we have scheduler in this location, this YAML file. So let me move the kube scheduler into the manifest folder. Now, if you see the manifest folder, we will be having the scheduler also into this path. Now let's exit from the node. Now let's do kubectl get pods in the kube system namespace. Now if you see, the scheduler started running for the past 15 seconds, which means scheduler started running, which means it will see the pending pod in the default namespace and it should assign a particular node to it and the pod should start running. Now let's check that kubectl get pods. Yes, it's running. Let's say even if you do kubectl delete pod nginx 2 and even you apply it once again, because the scheduler is running right now, it will be always able to run it. Yeah. So to quickly summarize the concepts that we have seen today, scheduler, the component which watches the pod which are in pending state and assign the node. If there are no nodes available, if the pod is having some specific criteria that the pod I want to run it in the GPU enabled node, it will be in pending state. But if it is able to schedule to a particular node, it will schedule it. And there comes the responsibility of node to take that pod and run it. Yeah, we saw about scheduler. Then we saw about, so which scheduler schedule the scheduler. Yeah, it's a little tricky. Which scheduler scheduled the scheduler in Minikube or kubeadm. So in this case, nobody is going to schedule. We are going to put that YAML in the static path, and kubelet will run it. Yeah, and more about static pods you can read about in this the Kubernetes official page. Yeah, coming back, I'll quickly show you how we broke the cluster in first place. Let me show you the script which I used to create the cluster. If you see here, we are doing kind create a new cluster, wait for all the nodes to be ready. Then it is waiting for the namespace and the service accounts to be ready. Then it is exec into the Docker and doing the move. Basically from the manifest path, it is moving the kube scheduler to the previous path, which means kubelet will get to know, okay, scheduler is not part of my static pods list. So it will remove it. It will get deleted. After that, we are creating the pod 1 and we are waiting for it to ready. Then we are creating the pod 2. Because pod 1 is having the name hard coded in the YAML file saying this is my node name, it never needs the scheduler. So it is always going into the running state. Pod 2, it needs the scheduler. So it was in the pending state. Once we have the scheduler, it is able to run it. Yeah. Hope you learned something about the Kubernetes components and internals. If you like the video, please like it, subscribe for more content like this. Thank you.